From our perspective on Earth, the Milky Way appears as a faint, glowing band stretching across the night sky, visible only in places far from artificial lights. We live on the outskirts of the Milky Way, in a region with far fewer stars compared to its densely packed center. The Milky Way is part of a cluster of galaxies known as the Local Group, a collection of around 80 galaxies of various shapes and sizes. The closest to us are the Large and Small Magellanic Clouds. The largest, by far, are the Milky Way and Andromeda, also known as Messier 31, named after its position in the Messier catalog. Our galaxy contains hundreds of billions of stars, and its name, Milky Way, comes from the ancient Greeks, who saw its soft glow crossing the night sky and called it the River of Milk. On a clear night, the human eye can see just over 2,000 stars, and nearly all of them fit within this circle. The Milky Way spans about 105,000 light-years across. This means that even if we could travel at the speed of light, it would take 105,000 years to cross from one side to the other. We reside in the outer regions of the galaxy, in a minor structure known as the Orion Arm, about 26,000 light-years from the galactic center. Even here, in this quieter part of the Milky Way, our stellar neighborhood is home to millions of stars. The Orion Arm is just a small branch between two of the Milky Way's major spiral arms, the Sagittarius Arm and the Perseus Arm. Our location gives us a unique advantage. Because we live in a low-density region, our night skies are clear enough to see the stars. But if we were somewhere more crowded, where stars are packed together far more closely, the night sky would be something entirely different. The galactic center lies in the direction of the constellations Sagittarius and Scorpius, tens of thousands of light-years away. Now, let's fly to the center of the galaxy. Our fastest spacecraft today can travel at about 60,000 kilometers per hour. At that speed, a journey to the center of the galaxy would take more than 450 million years. The sheer scale of this region is overwhelming. Over 10 billion stars are packed into the galactic core, lighting up space with an intensity unlike anything we see from Earth. We've arrived at the center of the Milky Way. Here in the center, also called the central bulge, the stars are much more numerous and the brightness is much more intense. Here, the difference is staggering. Stars are no longer scattered across vast distances like in our region of the galaxy. Instead, they are packed together in an overwhelming sea of light. In our neighborhood of the Milky Way, the average distance between stars is about 5 light-years. But here, in the central bulge, the density is far greater. And in this region, there are an estimated 10 million stars packed into every cubic parsec. That's millions of times denser than what we experience near the sun. In addition to light year, astronomers also measure distances in space using a unit called a parsec, which is about 3.26 light years. In this region, there are approximately 10 billion stars. The majority of these stars are ancient red giants. 80% of these stars were formed in the early years of our galaxy, between 9 and 13 billion years ago. They are the oldest stars in the galaxy. Many of them are twice the size of the sun or even larger, glowing with a deep reddish hue. But among them, scattered like cosmic fireworks, are brilliant blue supergiants, burning at temperatures tens of thousands of degrees hotter than our sun. And then there are the Wolf-Rayet stars, some of the most massive and short-lived stars in existence, shedding their outer layers at incredible speeds. This is a place of extreme stellar activity. Stars are constantly being born and dying. Supernova explosions are far more common here than in our part of the galaxy. These explosions enrich the interstellar medium, scattering heavy elements that will one day form new stars and planets. Being here feels like standing in the heart of a cosmic metropolis, a city of stars, endlessly churning with energy, movement, and transformation. Here, at the very core of our galaxy, lies one of the most mysterious and powerful objects in the universe, which we know as Sagittarius A star. Supermassive black holes must exist at the center of most large galaxies, perhaps all of them. The formation of supermassive black holes dates back almost all the way to the origin of the universe. They are older than many stars, and the information about their origins is still a mystery. A possible explanation for their formation is the action of gravity itself. Large clouds of gas are heterogeneous, so gravity is stronger at some points. Vast amounts of matter must have accumulated at the central point during the formation of the galaxy, forming the colossal black hole. Although Sagittarius A star is a supermassive black hole, it is relatively inactive in terms of consuming matter. Only small amounts of gas and dust fall into it occasionally, creating bursts of energy that we can observe from Earth. In 2019, an unexpected increase in its brightness intrigued scientists, suggesting that dynamic events are still happening around it. Sagittarius A star has the equivalent of 4 million times the mass of the Sun, or 1.3 trillion Earths, compressed into an infinitesimally small point. The black hole is so dense that a single teaspoon of it would weigh several tons and pass through the Earth like paper. It is possible to calculate the mass of Sagittarius A star by looking at the period and size of the orbits of the stars around it. The stars close to Sagittarius A star are called S stars. Unlike the glowing stars around it, Sagittarius A star itself is invisible. We only know it's there because of its immense gravitational pull, powerful enough to bend the paths of entire stars. Observations of the S stars orbiting Sagittarius A star were used to show the presence of the supermassive black hole and to produce data about it. We are seeing with very accelerated time. The closest stars orbit Sagittarius A star in a few dozen years, while the most distant ones take more than 500 years to complete a full rotation. Still, these are the fastest moving stars ever observed. They exceed the speed of 25,000 kilometers per second. With so many stars packed into this chaotic environment, could planets actually exist here? The answer is yes. Astronomers estimate that there may be as many planets in the Milky Way as there are stars, perhaps even more. And while most exoplanets we've discovered are in the spiral arms, a few have been found near the galactic center. One of them is Ogle 1093b. A gas giant exoplanet with an estimated mass between 0.59 and 0.87 times the mass of Jupiter. Followed by Ogle 51b. And even earlier, in 2006, astronomers discovered Sweeps 11, a Jupiter-sized gas giant orbiting dangerously close to its star, completing an orbit in just 10 hours. These discoveries confirm that planets can exist here, but so far, rarely are rocky, Earth-like worlds found in this extreme environment. Ogle 0677b, a super-Earth discovered in 2020. It has an estimated mass of approximately 3.96 times the mass of Earth, nearly 4 times the mass of our planet. If this planet has an atmosphere that allows you to observe the night sky, the nights will be full of stars. This region is far from peaceful. Supernova explosions are common, blasting space with deadly radiation. The intense stellar winds and high-energy particles would make life, at least as we know it, impossible. But it would still be a spectacular view. The sky would always glow, bathed in the combined light of nearby red giants, blue supergiants, and massive Wolf-Rayet stars. Some stars would appear hundreds of times larger than they do from Earth, and many stellar clusters would be visible relatively close. The quantity and proximity of the stars would make for an incredible spectacle in the night sky of this planet. If from Earth, with the naked eye, we can see about 2,000 stars, on this planet, we would see more than 30,000. If you enjoyed this journey, don't forget to like and subscribe to the channel for more journeys into space. Got a destination in mind? Share it in the comments. Thanks for watching, and see you on the next flight.